In our previous video, we looked at what would happen if our differential equation was not exact. And we found this integrating factor by this process that suggested that d mu dt, the derivative of our integrating factor with respect to t, should be m sub y minus n sub t over n. Now this was under the assumption that the partial derivative with respect to mu only depended on t. However, what if it depends on y as well? What do we do then? Well, this is one possible integrating factor that we could come up with via our procedure here. But if this assumption fails and we end up with a mu that involves y as well, this method really does not work anymore. So we have an alternative approach. And instead, let's suppose that we could possibly make the assumption that mu sub t is equal to 0. Mu sub t is equal to 0. So here we assuming mu does not have any t in it. Okay, so in this case, we can still go with this assumption. We just have to modify our equation here. And in this case, if mu sub t is equal to 0, then this term right here will equal 0. And that still suffices because then we'll get mu sub y times m plus m sub y minus n sub t times mu is equal to 0. And this still allows us to subsequently solve for mu with respect to y. This is simply d mu dy times m plus my minus nt times mu is equal to 0. Now, once again, this will work if what you find via this equation right here. So suppose this involves y. If this involves y, then we're going to take this alternative strategy right here. And now we'll basically get d mu dy instead of d mu dt, and it will still be an integrating factor. In this case, to solve for d mu dy, we'll have d mu dy equals the negative of my minus nt times mu. So just subtracting this over to the right-hand side. Now I'll rewrite the right-hand side, distribute in that negative, and that will give me negative m sub y, positive n sub t times mu. And now, oh, I forgot my m over here, and I have times m. And now when I divide by m, I get n sub t minus m sub y times mu divided by m. Okay, so this is an alternate integrating factor right here that will also work, and once again, this will work assuming that mu sub t is equal to 0. This right here will work assuming mu sub y is equal to 0. So mu here, if it doesn't have any y in it, then you're okay using this integrating factor, since mu does not have any y in it. But assuming mu does not have any t in it, this condition here, then you can proceed to use this integrating factor as an alternative.